Now we are in lesson 3.2. It's complex numbers. Now, first I will tell you why do we use it. And if you remember in the preceding lesson, I told you when delta is negative, I said no real root, but we have a root in C. So for example, guys, if you have this equation, x squared plus 4 is equal to 0. If I want to do delta or I want to solve it, you will get x squared equal to a negative number. And you know that this is no real root. This is impossible, but we have a root in C. We have a root as a complex number. So we replace minus 1 by I squared. So where we will reach x squared is equal 4I squared, and then I will square root both sides, and then I will have x is equal to I or minus 2I. So I have a complex root for this equation. So what is a complex number? A complex number has the form of a plus ib, or sometimes you can see x plus iy, where x and y are real numbers, or a and b are real numbers. We call this one the real part, and we call y the imaginary part. So everything next to I we call it imaginary part, and here we call it the real part. Now we will have some operations with the complex number. For example, here, if you have z is equal to plus 3i, what is the real part of z? It's 2. Imaginary part of z, it's 3. If z is equal to I don't have a real part. When the real part is 0, we call it its pure imaginary. This is here. And the imaginary part is 2. And when z is equal to a real part, just there is no imaginary. When the real part is 0, when the imaginary part is 0, I'm sorry, we say it's a pure real complex number. Now, how do we plot the geometric approach of a complex number? This one represents the x and this one represents the y. So as I'm plotting the point 2, 3, and then this is OZ, if this distance between O and Z, it's called the modulus of, or the absolute value of the complex number Z. So this is the point Z, and the distance between O and Z is called the modulo. So it's like the distance formula. So how do we find the distance formula? It's radical x squared plus y squared. It's x minus x0 here, and x0 is 0. So the modulus of a complex number, you know that it's all the time positive. The formula is radical x squared plus y squared. If I want to do it here, so it's radical 13. It means the distance between O and the complex number z is radical 13 units. Now let's do some operations with the complex number. So if I'm comparing two complex numbers, for example, if I have z1 is equal to z2, guys, it means when you compare two complex numbers, it means that I compare the real part should be equal to the real part, and the imaginary part should be equal to imaginary part. Now, if I want to find z1 plus z2, if z1 is 3 minus 4i and z2 is minus 2 minus 7i, how do we find z1 plus z2? We can add z1 plus z2. We add the real part. 3 minus 2 is 1, minus 4i minus 7i, it's minus 11. What does it mean, conjugate of a complex number? The conjugate of a complex number, we change the sign before the I. So if if it's plus, it becomes minus. If it's minus, it becomes plus. The notation of the conjugate in the IB is Z star. In the American or the Lebanese notation, it's Z bar. So if Z is 2 plus 4i, what will be Z star? 2 minus 4i. If it's pure real, the conjugate is still the same. So if Z is 4, Z star is also 4. Now, those are some formulas, and I will see why we have it. If you add z plus z star, it's 2 real of z. Why? Let's see it here. Z is x plus iy. Z star is x minus iy. When you add it, guys, you'll have x plus x to x, and the y's cancel each other. So it's 2 times the real part of z. If you subtract x plus iy minus x plus iy, so you'll have 2 iy, so it's 2 times the imaginary part. And z times z star, it's the modulus of that squared, because if you multiply it, it's a minus b, a plus b. So it's a squared minus b squared, and I squared is minus 1. It's going to be x squared plus y squared. Isn't this one the modulo squared? Yes. So that's why z times z star gives me the modulo of z squared. More application, guys. If it's given z1 is 4 minus 3i and z2 is minus 2 plus 5i. If I want to calculate z1 star, or the conjugate of z1, it's 4 plus 3i. The conjugate of z2, if you want, minus 2 minus 5i. Now, if I want to add, we did it before, We add the real part together, so 4 minus 2, it's 2 minus 3 plus 5i plus 2i. Now, if I have it as a fraction, this is what I really care about. 2z2 over z1. So first of all, I cannot keep it like this. I should write the answer as a plus ib or x plus iy. First, I multiply by 2, okay, and then as I'm doing the rationalization, I need to multiply up and down by the conjugate because what my objective is to have the denominator just as a real part. So what is the conjugate of 4 minus 3i? It's 4 plus 3i. Why I'm doing that? Because it's gonna become an identity a minus b, a plus b, and a squared minus b squared will cancel the I squared because it's gonna be minus 1. You will see how I will do it. I will multiply first or distribute minus 4 times 4 minus 16, minus 4 times 3i minus 12i plus 40i and plus 30i squared over this is a squared minus b squared, so it's 4 squared minus 9i squared. The I squared is minus 1, so it's gonna be 4 squared 16. Look at that, my mistake here, guys. Did you see that my mistake? Yeah, the teacher can also make mistakes. So it's gonna be 16. 16 plus 9, so it's 25, the denominator. I did a big mistake. It's okay. 25, 25, 25. So 4 squared is 16 plus 9, so it's 25. And then the numerator, I will add the real part together. I have minus 16 minus 12, I have minus 12i plus 40i gives me 28i. What is 30i squared? It's minus 30. Then I add minus 16 minus 30 gives me minus 46. So this is my final result. I can separate the real part and the imaginary part. So it will be minus 46 over 25. This is the real part. And plus I 28 over 25. This is the imaginary part of this complex number. So I know by the conjugate up and down. I developed and I will get the final answer. Look at it's in the form of a plus ib or x plus iy. Now, how do we find the modulo of z1? It's a formula. It's radical x squared plus y squared. So it's radical 16 plus 9, radical 25. It's 5. Example 2 is very important. This one. How do we evaluate radical 7 minus 24? So to be able to do that, it means I need to find the complex number that that are the roots of radical 7 minus 24. So radical 7 minus 24, so it's I need to find the complex number related to this one, a plus ib. Now a and b are real. A should be real and b should be real. So to be able to find a and b, you need to compare real equal real, imaginary equal to imaginary. But first of all, I need to cancel this radical, so I need to square both sides. I will have 7 minus 24 is equal to a plus ib squared. I develop the identity. It's a squared plus 2ab, so plus 2 times a times ib plus b squared and plus I squared b squared. I squared is minus 1. I replace it. It's here. I can see this is the real part and this is the imaginary part. Now I compare real equal real. It means 7 should be a squared minus b squared. Imaginary equal imaginary. 2ab is equal minus 24. And then now I need to solve it. It's a system of equations. So now I have two equations. You take the second one and then I will find b in terms of a or a in terms of b. It's your choice. And I will replace b in the first equation by minus 12 over a. I will get a squared minus the minus here is still here. Minus 12 plus 144 over a squared minus 7. I will do same denominator. Multiply all by a squared. So I will have here a4 minus 7a squared minus 144 equal to 0. A fraction is equal to 0 and my numerator equal to 0. So I will solve numerator equal to 0. This is as a quadratic equation, but you need to be careful. The roots are not a is equal, it's a squared is equal, because here I can write it like this, like a squared squared. Okay, so as I have x squared minus 7x minus 144. A squared is equal to 16 gives me a is equal 4 or minus 4. So for a4 to find b, it's minus 12 over a, so it's minus 12 over 4, it's minus 3. And if a is minus 4, so b is a 3. So the two complex number that I have are 4 minus 3i minus 4 plus 3i. The second root here, it's a squared is equal to minus 9. It's impossible. You cannot tell me, Miss, why I can write 9i squared. I cannot because I said already that a and b are two real numbers. So I cannot replace the minus here by by I squared. The last example, how do we simplify when I have a big exponent for I? All the information, the only information that I know, guys, that I squared is -1. So I need to decompose to have I squared. So I3, how we decompose it to have I squared? It's I squared times I. I12, it's an even number, so I can write it I2 exponent 6. -3. I13, it's an odd. I cannot write it I squared exponent something. So at first I need to compose it to the nearest even number. So it's I squared times I, and exactly for I7, it's I6 times I. Now instead of I squared, it's -1. -1 times I gives me minus I. -1 exponent 6. The I12 now I can write it I squared exponent 6, and the I6 I12 exponent 3. And instead of I squared, I can put -1. I continue my work. It's minus I -1 exponent 6. It's 1 because it's even exponent. Now here it's -1 exponent 6. It's 1 times I times -3, so it's -3I. And here it's -1 times 4I minus 4I. Then I add the real together, the imaginary together. I think, guys, I'm going so fast. I'm sorry, but because it's very simple. So it's 1 minus 8I, and then I got the final answer in the form of a complex number. So every time you have i's with a big exponent, if it's even, you write it as a square exponent, another exponent. If it's odd, you decompose it as even times something, and then you you will simplify.